Welcome. This is a technical commercial briefing for the Qualys AI Triage Pack by Miyabi Threatworks Solutions. What you're about to see is an AI-driven approach to vulnerability triage and reporting, focused on one goal: turning raw Qualys scan exports into consulting-grade deliverables that you can actually present, share, and operationalize. Over the next slides, I'll walk you through the challenge we're solving, what the pack generates, how the pipeline works end-to-end, and the dashboards that transform vulnerability noise into clear prioritization, clear narrative, and a repeatable decision process. Now let's talk about the real challenge behind vulnerability management with Qualys. It's not scanning, it's triage. In most environments, Qualys produces an enormous volume of findings, and the default workflow becomes a pile of CSV exports that analysts need to manually filter, sort, group, and interpret. The problem is that a CSV is just raw output. It doesn't carry decision context. It doesn't tell you what is actually exploitable in your environment, what is likely to be hit first, which assets are business critical, or which findings are duplicates, noise, or false positives. So what happens is analysis paralysis. Teams spend hours manipulating spreadsheets, arguing over severity, and redoing the same analysis every cycle. And when triage is manual, you get 3 technical failures at once. First, it's slow, because it's human-bound and doesn't scale with the number of assets or vulnerabilities. Second, it's inconsistent, because 2 analysts can look at the same vulnerability and reach different conclusions based on personal judgment, fatigue, or missing information. Third, it's hard to audit and reproduce, because the decision logic lives in someone's head or in ad hoc spreadsheet filters, not in a deterministic pipeline that can be rerun and validated. From an executive standpoint, the issue is even worse. Leadership doesn't need thousands of raw findings. They need a narrative. They need a clear explanation of what the main risk drivers are, where the exposure is concentrated, what the top remediation priorities are, and what the expected risk reduction is if we implement specific controls. And for consultants, deliverables must be repeatable and offline friendly. You need a format that can be shared as a clean report, presented in a meeting, and reused across clients, without relying on fragile manual steps or access to the platform at presentation time. Governance demands deterministic scoring and transparent prioritization. If you're managing risks seriously, you need to explain why something was prioritized, what signals drove that score, and how the same methodology would behave next week or next month. That is exactly the gap this pack closes. It turns Qualys raw data into structured, consistent triage decisions and outputs that are built for reporting, auditing, and action. Alright, so what is the Qualys AI Triage Pack in practice? It's a Python-based application that takes raw Qualys CSV exports and turns them into consulting-grade deliverables, meaning outputs you can use in real meetings and real engagements with a consistent methodology. The first stage is input processing. Here we ingest the Qualys CSVs, normalize the data, and standardize fields that are usually messy across exports. Things like host identifiers, detection metadata, timestamps, QIDs, CVS, severity indicators, and any environment-specific tags you include. The goal is to turn spreadsheet chaos into a structured dataset that the pipeline can reliably reason about and reproduce. Next comes the core triage logic. We select and prioritize the top X vulnerabilities. This is where we combine customizable deterministic scoring, your rules, weights, and governance logic, with LLM-based rationale. The important point is, the LLM isn't being used as a random severity generator. It's being used to produce a human-grade explanation for why an item is prioritized, and to convert technical signals into a narrative that is readable by both technical and executive audiences. Then we generate 2 layers of reporting. First, detailed technical reports, with enough depth for remediation teams and security engineers to act. Second, executive-friendly narratives, concise, structured, and decision-focused. This is what transforms vulnerability listings into risk communication, which is usually the missing piece in vulnerability management programs. After that, we render a complete static HTML report site, including assets, CSS, and custom branding. This is key for consultants and internal security teams because it becomes offline friendly and portable. You can ship it to a client, store it as an artifact, attach it to tickets, present it in a meeting, or archive it for audit purposes without requiring live access to Qualys or dashboards during the conversation. And finally, the pack is designed for integration. It can handle notifications and data delivery through channels like Slack and email, and it can also integrate with systems like OpenSearch for indexing, searching, and building longer-term analytics pipelines. So overall, what you're looking at is an end-to-end automation pipeline. Ingest raw Qualys data, apply deterministic triage logic, enrich with AI rationale, and output professional deliverables consistently, repeatably, and at scale. Now let me break down the pipeline architecture, because this is where the pack stops being a report generator and becomes a repeatable triage system. Step 1 is ingest. The pack starts by parsing one or many Qualys CSV exports using a simple glob pattern. That means you can point it to a folder of exports, weekly scans, multiple asset groups, multiple business units, and it will ingest everything in a single run without manual merging or spreadsheet work. Step 2 is normalize. Qualys exports often vary depending on the report template, the scan profile, and the module being used. So here we map the raw fields into an internal domain model. Consistent identifiers for QID, CVE, title, severity, detection age, asset metadata, tags, and any custom columns you use for ownership, environment, business criticality, or exceptions. This normalization step is critical because it ensures the logic behaves the same way every run. No surprises due to formatting changes. Step 3 is aggregate. Instead of treating the output as a flat list, we group findings by QID and by asset scope. This is where the pack starts producing intelligence. It can tell you not only what vulnerabilities exist, but how concentrated they are, which QIDs are exploding across the estate, which ones hit crown jewel assets, and which ones are isolated edge cases. Step 4 is select, and this is the deterministic decision layer. The pipeline applies your selection logic to compute a prioritization score and then selects the top X items, while honoring constraints. Those constraints are important in real environments. You may want to avoid flooding the top list with duplicates. You may want category diversity. You may want to enforce that certain asset tiers always appear, or you may want to reduce noise from low signal findings. This is where governance lives. The prioritization becomes reproducible and defensible. Step 5 is enrich, the AI layer. At this point, the set is already selected deterministically. The LLM is used to generate rationales and narratives, explain the risk in human terms, summarize technical impact, highlight likely attack paths, and translate the output into something that different audiences can consume. And because this happens after selection, the AI is augmenting the deliverable, not controlling the decision logic. Step 6 is render. The pack uses Jinja 2 templates to produce a fully static HTML report site. This is not a dashboard you need a backend for. It's an artifact. You can version it, archive it, ship it, or attach it to tickets. It includes the assets and styling, and it supports custom branding, so consulting teams can deliver it professionally. And step 7 is notify. Once the report is generated, the pipeline can push notifications and outputs to where teams actually work, Slack, email, or integration points like OpenSearch, so you can index the results, build trends, and plug it into broader workflows. So the key message here is the separation of responsibilities. Core logic is deterministic. The AI enrichment is generative, and the outputs are designed to integrate cleanly into real operational processes. On this slide, I want to make the pack feel concrete, what it consumes, what it produces, and how you control the entire behavior through configuration. Starting with inputs, the pack consumes one or more Qualys CSV exports. Practically, you place the exports into a configured input directory and the pipeline ingests them in batch. This is important because real customers don't have one CSV. They have multiple exports per week, per asset group, per BU, sometimes split by scan profile or tags. The pack is designed to accept that reality. You also have a configurable file pattern using glob, so you can target exactly what you want. For example, only *.csv, or only files that match a naming convention like prod_*.csv versus dev_*.csv. And we support common encoding and delimiter parameters, UTF-8 by default, which matters because exports can vary depending on locale, Excel workflows, or custom report settings. The goal is ingest reliably every time without manual cleanup. Now the second pillar is configuration, and that's done through a centralized config.yaml. This is intentional. We want the pack to behave like an auditable system, not like a one-off script, and we keep secrets like API keys out of the YAML. Those are injected via environment variables, which is standard operational hygiene. Inside the YAML, you control the major behaviors of the pipeline. Under selection, you define the top X count and the constraints. For example, diversify by host, avoid duplicates, enforce certain coverage rules, or ensure the output isn't dominated by a single recurring QID. Under limits, you can set guardrails for performance and predictability. Max rows scan, chunk sizes, and text caps, which is critical when you're dealing with very large exports. Under OpenAI, you control the LLM behavior, model selection, temperature, token budgets, and timeouts. This matters for consistency. You can tune it for more deterministic phrasing or allow more variability depending on your use case. Under rendering, you define themes, template paths, and branding toggles, logo on/off, styling, and output formatting, so the deliverable matches your consulting brand or internal reporting standards. Now let's talk about the key benefits and what truly differentiates this pack from a generic AI report approach. The first and most important point is deterministic core scoring. This pack is built reliability first. The prioritization and selection are driven by transparent, repeatable logic, not by AI guessing risk. The LLM is used only for narrative enrichment, and even then it's constrained. That means you can rerun the same data set and get the same prioritization outcome, which is essential for governance, audit, and operational trust. That ties directly into AI guardrails. We don't let the model generate freeform content and hope it's correct. The output is constrained into structured narrative, JSON, with explicit fields and boundaries. This reduces hallucinations, makes the output easier to validate, and allows the rendering layer to remain deterministic. So AI adds value where it should, turning technical signals into human explanations without corrupting the underlying triage logic. Next is offline-friendly delivery. Instead of requiring a live dashboard, a backend, or a platform login, the pack generates a self-contained static HTML site. That gives you a deliverable you can email, archive, attach to tickets, and present in meetings, even in restricted environments. In consulting, this is huge. You're not depending on access or connectivity to show results. The deliverable is portable and secure by design. Then we have audit-ready outputs. Every finding in the report can be traced back to the source CSV row, and the selection logic is transparent. This is critical for regulated environments and mature security programs. You need to answer, why was this prioritized? And where did this data come from? without relying on tribal knowledge or manual spreadsheet steps. The next differentiator is consulting-grade packaging. You get two audiences served at once: technical depth for engineer, remediation context, impact, and actionable guidance, and executive summaries for leadership, clear narrative, top priorities, and decision framing. This solves the common failure mode where teams either ship a raw vulnerability dump or they ship an executive summary that's too shallow to act on. And finally, we design this with enterprise features in mind. Localization support through I-18N, so you can produce reports in different languages with simple config settings, custom branding, and integration points. Out of the box, the pipeline is designed to connect into operational workflows via Slack, email, OpenSearch, and tooling ecosystems like Metabase. So the main takeaway is the pack is not AI doing triage. It's deterministic triage with AI used in a controlled way to produce explanations and narratives, plus deliverables that are portable, audit-ready, and built for professional reporting. All right, now we're entering Section 03, Dashboards Overview. This pack ships with 9 specialized dashboards that complement the action plan, from executive-level summaries to deep technical and threat-driven views. The idea here is simple. Instead of giving you one generic report, we provide multiple perspectives for different audiences: leadership, GRC, engineering, and security operations. On this slide, you can see the full list: executive, risk/GRC, attack surface, lifecycle and obsolescence, compliance mapping, trend, probable attack paths, MITRE ATT&CK, and ransomware assessment. Now what I'm going to do next is go one by one, quickly explaining what each dashboard answers and how you use it in real triage and reporting. First dashboard is the executive dashboard. The goal here is to give stakeholders a clean, decision-ready view, focused on KPIs and high signal charts, so leadership can prioritize without getting buried in raw findings. At the top, we surface posture indicators like coverage, total findings ingested, unique vulnerabilities, and hosts observed. This answers 2 executive questions immediately. How big is the exposure, and how trustworthy is the dataset and scan scope? Then we summarize the severity posture to show distribution and concentration, and we highlight exposure surface and top systemic vulnerabilities, meaning the issues that repeat across the estate and create structural risk. We also show most affected assets, so the conversation becomes: where is risk concentrated, what's systemic, and what should be fixed first? This dashboard is configurable. You can enable or disable it, and you can apply custom branding, and it's built from normalized scan metadata, findings by QID/severity/category, and asset identifiers like IP, DNS, or NetBIOS. The primary use cases are posture assessment, systemic issue detection, concentration analysis, and scope validation. Next is the risk report, GRC-style. This dashboard is designed to translate vulnerability data into a formal risk register using deterministic scoring and tiered rankings, typically critical, high, medium, and low, with clear treatment guidance. Instead of discussing a list of vulns, you're now discussing risk items, aggregated, normalized, and prioritized in a way that's consistent with governance workflows. At the top, you get the overall counts, total risks, how many are critical and high, plus a risk index view and the distribution chart so GRC can understand posture at a glance. Then you get structured breakouts like tier distribution, risk score distribution, top categories, and top affected assets. This is important because risk teams often need to answer questions like: what categories dominate our risk register, where is the concentration, and which business units or asset groups are carrying the highest exposure. At the bottom, the top risks table is where this becomes operational. Each item is a single risk entry with a score and tier mapped back to the underlying technical identifiers: QID, title, severity, and enriched with context such as threat/impact signals and CVE references. That makes it usable for multiple workflows, GRC reporting, risk acceptance discussions, prioritization, and remediation tracking. And just like the rest of the pack, the split is intentional. The risk scoring is deterministic, while AI is used only to help with narrative fields when enabled, meaning you get governance grade consistency first and optional narrative enrichment second. Next dashboard is the attack surface snapshot. The purpose here is to provide an exposure-oriented view of the environment, analyzing port concentration, protocol diversity, TLS posture, and exposure hotspots, using only the data you already have in the Qualys exports. No external scanning is required. At the top, we start with a few core exposure KPIs. How many unique hosts we observed, how many unique surface keys we can derive. Basically combinations like protocol/port, what the most common exposed ports are, and how many hosts have high severity findings associated with any exposed service. This is a fast way to move from vulnerabilities into exposure reality. Then we break it down into actionable exposure analytics. Port concentration shows where services are clustered, which ports dominate the estate, and which ports create the largest blast radius. This helps identify systemic exposure patterns like widespread remote management ports, legacy services, or unexpected service sprawl. The dashboard also highlights protocol split, how much of your surface is TCP versus other protocols, and it compares TLS versus clear text/unknown on the top ports. That's important because encryption posture is often a quick proxy for maturity, and it also helps detect risky combinations like high-value services running without TLS or with inconsistent TLS visibility. Finally, we call out high-severity hotspots, where severe findings intersect with exposed services. This is key for prioritization. It's one thing to have a critical vuln somewhere. It's another to have a critical vuln on a service that's broadly exposed across many hosts. So in short, this dashboard answers, where is my attack surface concentrated? What services are most common? How healthy is TLS posture? And where are the highest severity exposure clusters? Which makes it extremely useful for scoping, quick posture reviews, and targeting remediation efforts where they reduce real-world exposure fastest. Next is Lifecycle and Obsolescence. This dashboard is a modernization driver. It highlights end-of-life, obsolete, unsupported, and deprecated technologies, and shows how widely they're spread across the environment. The reason this matters is simple. A lot of vulnerability risk isn't one bad CVE, it's structural tech debt. When you have outdated runtimes, legacy platforms, or EOL operating systems, you're effectively guaranteeing recurring vulnerabilities, limited patch availability, and higher operational risk. This dashboard makes that visible in a way that's usable for planning and budgeting. At the top, we summarize lifecycle exposure, how many hosts are affected, how many lifecycle items were detected, what the top lifecycle item is, and which platforms or OS families are present. Then we visualize lifecycle findings by severity and show platform distribution, so you can immediately see whether you're dealing with a Windows-heavy legacy problem, Linux packages, network appliances, or mixed estates. The bottom half is where it becomes operational. We show catalog coverage and the top catalog families, which helps validate detection quality and identify where the estate is drifting into unsupported stacks. And then we list the top lifecycle items, the recurring EOL components or deprecated software families driving the majority of the exposure. Under the hood, this view is built from the normalized vulnerability identifiers and categories, plus the evidence fields that hint versions and product families, combined with asset identifiers, so you can tie lifecycle risk back to real hosts and real technologies. Primary use cases are very practical: building a modernization business case, making tech debt visible to leadership, planning migrations, and identifying support contract or vendor lifecycle risk. Basically, turning security findings into an actionable modernization roadmap. Next is compliance mapping. This dashboard gives you a compliance lens over the same vulnerability dataset with PCI-focused metrics, deterministic control domain mapping, and optional framework crosswalks when you want to translate findings into audit language. The first thing we do is separate what is explicitly PCI, flagged in the Qualys data, versus non-PCI findings, and we show the posture difference. That's useful because compliance teams often need to answer very specific questions like, how many PCI relevant findings do we have? How severe are they? And how many hosts are impacted? Then we map findings into control domains using deterministic logic, meaning it's not a subjective mapping. This creates a practical bridge between technical vulnerabilities and governance categories like vulnerability management, secure configuration, access control, logging and monitoring, and so on. On the dashboard, you can see which control domains carry the highest weighted impact, which ones are driving the most unique vulnerabilities, and which ones affect the most hosts. This is exactly what enables control gap analysis. Instead of saying we have 5,000 findings, you can say our dominant weakness is in secure configuration and patch/vulnerability management, and it's affecting X scope, which is much closer to how auditors and compliance stakeholders think. From a data standpoint, it relies on the PCI vulnerability flag and severity, plus category/title/solution fields, and CVE identifiers for cross-mapping. And if you enable the framework layer, the pack can produce crosswalk-style narratives that help align the same issues to common frameworks, but the backbone remains deterministic. Primary use cases are straightforward: PCI compliance checks, control gap analysis, framework alignment, and audit preparation, turning technical scan output into compliance-ready evidence and prioritization. Next is the trend dashboard. This one is about turning vulnerability management into a measurable program, not a weekly fire drill. The goal is to visualize historical scan data so you can track coverage stability, remediation velocity, and recurring vulnerability patterns over time. At the top, you select the scan series you want to analyze, basically the history stream, and we surface the latest KPEs, current coverage, total findings, unique vulnerabilities, and the latest risk index. The important part is the deltas. It shows how the current run compares to the previous one, so you immediately see if you're improving or regressing. Then we plot the core trends. Coverage over time tells you if your scan scope is stable, because without stable coverage, metrics lie. If coverage changes, we detect that, so you don't accidentally celebrate a risk reduction that was actually just fewer assets scanned. Next, we track findings and unique vulnerabilities over time, which is a direct proxy for remediation velocity and hygiene. You can see if the organization is burning down backlog or if findings are accumulating. We also track severity bands over time, so you can validate whether critical/high exposure is actually going down, not just overall counts. And finally, we show a risk posture index over time, which summarizes the trajectory into a single trend line that's easy to communicate to leadership and use for SLA monitoring. This dashboard is especially useful for 4 things: remediation tracking, SLA monitoring, scope validation, and detecting recurring systemic issues, meaning the same vulnerability families returning repeatedly because root causes weren't addressed. It's the piece that makes the pack usable, not just for one scan, but for continuous vulnerability management maturity. Now, these next two go together. This is the offensive mapping layer: probable attack paths and MITRE ATT&CK mapping. On the left, probable attack paths models likely chains and pivots based on what we see in the findings, so it connects vulnerabilities and assets into possible progression paths. It's explicitly hypothesis-based. We state assumptions instead of claiming confirmed exploitation, and we provide a clear visualization of how an attacker could move through the environment. Optional AI narrative can summarize the story, but always in a guardrailed, narrative-only way. On the right, MITRE ATT&CK mapping translates the vulnerability aggregates into likely ATT&CK techniques and tactics. We validate technique IDs against a local catalog for auditability, and we provide a compact matrix-style view with drill-down evidence. And if needed, we add an executive narrative tab so leadership can understand the tactical risk profile without reading technical details. So the takeaway is, these two dashboards shift the conversation from CVES and severities to attacker behavior and realistic pathways, quickly and in a defensible way. Next is the Ransomware Assessment Dashboard. This is one of the most practical views in the pack because it converts vulnerability posture into a susceptibility model, combining likelihood and impact, using deterministic scoring, and it adds a what-if simulator so you can test how specific controls would reduce the risk. At the top, we calculate a baseline risk index and an adjusted risk index. The baseline represents the environment as observed. The adjusted view lets you incorporate control assumptions. Basically, if we implement X, how much does the posture improve? We also show coverage so you understand how complete the data set is before interpreting the score. Then we break risk down across groups because ransomware is rarely uniform across an environment. Some segments, like legacy server pools, endpoints, exposed services, or specific business units, carry disproportionate exposure. The dashboard shows distribution across groups and a likelihood versus impact view so you can identify which groups are both easy to compromise and high impact. Under the hood, the model uses multiple drivers that are strongly correlated with ransomware outcomes: severity and exploitability signals, exposure indicators like ports and protocols commonly abused in ransomware operations. Think RDP and SMB patterns, and lifecycle/obsolescence factors like outdated OS stacks that increase the probability of successful compromise and lateral movement. The key capability here is the controls simulator. You can model how mitigation controls affect the index, things like stronger segmentation, hardening remote access, improving backup strategy, reducing privilege exposure, and similar measures. And the dashboard recalculates the posture. This turns the conversation from "we have vulnerabilities" into "these are the control investments that most reduce ransomware risk." So this dashboard is used for consulting-grade risk communication, susceptibility modeling, control simulation, asset group ranking, and deterministic scoring that leadership can understand and engineers can act on. All right, to wrap it up, if you want to deploy this workflow in your own environment, you can get the Qualys AI Triage Pack today. This is offered under a commercial license with a seat-based model designed for both consultants and enterprises. And the key point is that you can share the generated outputs freely with your clients and stakeholders because the deliverables are portable and self-contained. Getting started is straightforward. Download the pack, adjust the YAML configuration to match your workflow, drop your Qualys CSV exports into the input folder, and run. In minutes, you'll have consulting-grade HTML reports and dashboards ready to present, and it's built to be production-ready, with branding controls, localization support, and integration options for common channels like Slack and enterprise tooling. If you'd like to try it, the link is on screen. Get it now on Gumroad. And you can start turning Qualys exports into repeatable triage decisions and professional deliverables right away.